Lists in Python. There are times in programming where we must store many values, not just one or two. In these cases, it is not practical to assign a variable or identifier to every value. For example, let's say we want to write a program that will store a student's grades for the marking period. There are 15 assignments. Would you declare 15 different variables? Furthermore, if you had a total of 80 students, would you declare variables for each of them, like this? We can see how it is extremely impractical to declare such a vast amount of variables and be able to keep track of them. More importantly, even if we did, what would happen the next marking period? Would you create 15 new variables? Would you delete all the values stored in the first 15 variables? Python has 4 ways of gathering data types into a collection: lists, tuples, sets, and dictionaries. In this course, we will only be focusing on lists. However, you can quickly Google the others to see how to use them if the need arises for you. A list is a collection which is ordered, changeable, and allows for duplicate members. A list can help us in this grades scenario because it can hold and work with a list of values. They work similarly to a spreadsheet using rows and columns that store data in each box or compartment. Here is a visual of our grades list. Below, we have included 7 scores, but it can get as long as you want. Notice how the position or index of the first grade actually begins at 0. So the index value is how we're going to access each of these compartments. The index value here is 0. The second box has an index of 1, then 2, 3, 4, 5, 6. So a list of 7 items will have an index value up to 6. Remember, the first box, or the first spot, always has an index value of 0, not 1. Here is the Python syntax for initializing a list. This is the name you assign to your list, then an equal sign, and then square brackets to hold the elements or contents of your list. We separate each element with a comma. Remember that string elements are going to go inside of quotation marks. Each element in a list can be accessed by its index or position in the list. The first element has an index of 0, then 1, then 2, and so on. For our grades program, we can start by initializing a variable to hold a series of grades like this. Grades equals square brackets, and then we have 5 grades like that. We can work with each individual grade by using this notation. So you have the list name, then square brackets, and then you include the index value of the compartment you are trying to access. So therefore, grades 0 would be 82, grades 1 would be 73, grades 2 is 95, grades 3 is 100, grades 4 is 87. And don't forget that index values begin with 0, not 1. The first item in the list has an index value of 0. This is very important. For example, if you want to print out the first grade in the list, you would write this command: print grades 0. This will print out 82. Here's an example of a list that contains strings. As you can see, each food item is wrapped in quotation marks. The command print foods 2 will print out kale, because foods 0 is bananas, foods 1 is bread, foods 2 is kale. However, if you were to run this command, print foods 3, you would get an error. It would say index error, list index out of range, because there is no item in the list with an index value of 3. On the AP exam, you may see either of the following expressions of a list created in AP Pseudocode, depending on whether the problem is using text-based or block-based code. It looks very similar to the Python statements with the exception of the arrow used to show storage of content. Lists written in AP Pseudocode also use index values to access specific elements in the list. Accessing elements in an AP Pseudocode list looks much the same as gathering elements from a Python list. The biggest difference with AP Pseudocode lists is that the first index value is 1, not 0. So here, the index value is 1, 2, 3, 4, 5. This code will output 82, and this code here will output 73.